available, but Z is sitting inside R. Z is inside R, right? Z as a subset, it sits inside R. As an algebraic object, you have addition as a binary operation. So that makes Z plus as a group, as an abelian group. And R is also a group, but it's an extended one. But not only R, see, we are playing with R as I mentioned from algebra, but R is much more better. I mean, we are celebrating with R just because it has fine, fantastic structures, not only with the algebraic structure, just a group structure is not enough for us to talk about that. So this group structure, we are doing analysis. Can you just say what is analysis, what it does? Is there any difference between algebra and analysis? If I am just terminology wise, if I am saying algebra and analysis, how will you differentiate or how will you connect them? No part of mathematics is an island, right? So algebra is we are talking about, and analysis also another word we are using it. So from the algebraic point of view, you are doing with sets and relations, functions, and binary operations on that. So you will be getting groups, rings, fields, etc., etc. So our R is a group as well as something more you can say. Analysis on this R, whenever I am trying, see these are all algebraic concepts. Whenever I am talking about group, field, ring, and everything like that. But if I want to do some analysis on this particular group, for example, R under addition, what should I mean? How analysis, the terminology differs from algebra? Can somebody just say something? Is there a fundamental difference between these two branches? From your experience, from your graduate experience, undergraduate experience, all such things. Is it audible? Hello?
Yes, sir.
Yeah. Yeah, fine. So can somebody say analysis is doing something? Algebra is also doing something. So algebraic objects are something like group. Some examples are, you said so many, Z plus, R plus, etc., etc. So this R plus, if I am considering a group, what kind of things what I am doing with analysis tools? What is the fundamental difference? See, whenever you are saying algebra and R under plus, most of the time you are working with finite process. Am I right? See, you look at two members. What do you mean by a group? R under addition is a group. It means what? It satisfies some things. What is that? A binary operation is available. So any pairing you take, you can add them. It will sit inside. Associativity allowed to extend. Then something more. What are they? Identity element and inversion. Yeah, fine. And commutativity also you can say. This is what is meant by a commutative group. Fine. But will this structure allow you to go infinites? I mean infinite operations, infinite process. See, for example, 1, 2, 3 if I am giving, you can add 1 plus 2 under this operation. Associativity help you to say something like that. 1 plus 2 plus 3 plus etc. up to n also it will be allowable because of induction if you are assuming with or utilizing with associativity. So you will be getting some notion of the summation up to any finite number of terms. But if I am simply asking 1 plus 2 plus 3 plus etc. etc., I am not ending up with that. And such a process, is there some exist or something? Can algebra can answer you? Or these group structures or axioms will give you answer?
No, sir.
No. What is the problem there? See, whether such a entity exists or not, that is a second thing. You may approach the subject in many different ways. In the sense that you may stop at somewhere, you can go further. So induction will allow you to say how far in the finite process you can go. But if once you are away from this finite process, algebra is some sense helpless. You have to take some more tools. Whenever you are trying to say what exactly a summation or this means, I mean all the natural numbers. So our beginning point is always natural numbers. Remember that. Natural numbers is a set. It is equipped with addition. It is not only equipped with binary operation addition, it also equipped with multiplication. Am I right? The usual multiplication.
Yes, sir.
Yeah, there are so many nice properties with natural numbers. Very, very nice, crucial, fundamental properties. So you can add them. You can even talk to any finite stage, but this, it keeps mum. Your algebra won't help you. Even if you want to attack on this problem, what is your, how will you tacit this thing? Suppose an S exists, you have to look for partial sums like this. 1 plus 2. Am I right? S1 you can call 1. S2 you can call 1 plus 2. S3 you can call 1 plus 2 plus 3. They are called partial sums. You can partially add them. And you will try these fellows. These fellows means they will actually give you a sequence. Then finally you have to answer whether this has a sensible real number where this can go. Am I right or not?
Yes, sir.
Yeah. So this process is the last process. Essence are made well defined well with the finite process of algebra and the group structure. Not exactly n is not a group at all, but at least binary operation is well, and associativity is also enough for that. So it defines well all these fellows, but still if you are asking where it should go, this process where calculus addresses first as the process of limiting. Am I right? So limiting comes into the picture if you want some notion of this kind of things. So that's what the fundamental difference. I mean, calculus is the beginner or the beginning point or the primary classes of analysis. So calculus is doing the infinitesimal process. So that is the fundamental difference. Algebra will help you a lot. It's very generous, as Afrale says. But whenever finiteness is missing, you have to take some more tools other than that. That is where analysis comes into the picture. So you can just think about whether such a summation exists finitely or not, such things using partial sums and all. That is not important now. It may not be summable in the usual ways because it may have a notion of approaching infinity and all. So you have to say a lot of things, why it is not making any sense, whether it is bounded, unbounded, such things you will utilize well. So why you are not expecting any summation, any sum fellow S, which is in N or a bigger space in R is not existing as a sum? That is another question. For that, you have to say something about boundedness and all. But so boundedness automatically relates to the order relation. So if I'm just looking even the very fundamental setup, that is natural numbers, you have addition there, you have multiplication there, you have the comparisons, I mean the relations which keeps order. So this makes almost a fruitful structure of natural numbers. Am I right? So whenever I'm just saying an algebraic object, which is the natural numbers, set of natural numbers, I must consider all these: a set, two binary operations with its interlinking properties, and of course, the notion of a relation. Notion of a relation, I mean less than, usual less than comes into that. This actually gives the order relation. So all this order relation and has to do and has to say so many things to us. So using order, you can compare them. You can have a well ordering property. What do you mean by well ordering? Can you just remember your days of a degree? Hello? If I'm just saying that natural numbers are well ordered. See, is it clear what I'm saying? N is a set. Addition is well defined as a binary operation. Two natural numbers added together will be a natural number. So CTT will hold well. But identity will miss. It's not a group. You can talk about multiplication. That's also closed. Associativity holds. Everything is fine. Even 1 is existing as a multiplicative identity. But what about less than? Less than is also well defined. How will you define on that? That is a different thing. So natural numbers, all these things, once you know with the usual or natural additions, multiplication as well as order, that's a good tight structure now. So with that less than, you can talk about least element, about subsets and all such things. So what do you mean by well ordering? That's what I'm asking. Anybody remembers? It is a well ordered sets. It's a very fundamental property. Whenever you are extending, you will miss something. Well ordering means every non-empty subset you are trying to look at, you have a starting point. Because natural numbers, the basic things are like that. Peano's axiom you used to know. That is, you have to start up with some one. I mean, then successors are coming. All such things are well known from the basic levels. If you are interested, you can just check for such things. But anyway, we are taking that we know about a little bit, at least a little bit about this structure n. So with this structure, you will try to extend. See, whenever you are trying to solve out, I mean some equations from the algebra side, you will find the necessity. See, whenever you are saying that 2 plus 3 equals 5, the natural question is 2 plus what will give you 5. So it is an unknown process which you have to put it something, equations comes and you have to answer it through. But if I'm simply asking 2 plus 2 is, see, something like 2 plus what will give you 2, then you have to introduce your 0 and whole numbers comes into picture. Later integers also mark into the side, because something like 3 plus what will give you 1, if I'm asking in the natural number system, not only adjoining 0 with you have to adjoin all negative integers. That is why you are developing to z, we are calling it off. So the development of n to z, it is not merely a set theoretic inclusion, it also carries all these structures along with you. Addition with natural numbers, multiplication what will happen, and the less than, the order also how it is extended. Well, they are properly extended. So n, as whenever I am writing this notation, n is sitting inside z, very naturally or canonically I will say n is inside z. N is a subset of, you can see that n is sitting inside z, not merely as a subset. It take care of your addition already defined on n. It take care of multiplication well and order also. So these structures, whatever be the attributes you are trying to give with n, addition, multiplication and less than, that also preserves well with the whole notion of z, not only set theoretic, even geometric also, later you will see. So addition, multiplication and less than also compatible. These are compatible structures. That is what is the best. Hello? Are you getting me? What I am saying?
Yes, sir. Keka.
Yeah. So n to z, whenever you are moving, you are always moving along with the structures. Addition, multiplication and z. As you said, z under plus. If you are looking at, that is, that may be your first experience as a group. Even though I have to object that it is not the most natural group. That example is very fine. In fact, it is a group. Somebody said there are so many cyclic groups, abelian groups. So we are not satisfied with z also. Why you are not satisfied? See, equations are solvable in some sense, but not all kind of equations. Suppose you are manufacturing new equations out of this z. So polynomials, that is comes very naturally in algebra. That is why the unknown process is taking place. That is the first experience for mathematics whenever you are looking at. There are two aims for mathematics. From the physical world, whenever you are trying it out, application side, if you are taking it out, measurement comes very interesting way from the old days. But obviously from the other side, the modernized way, if you are looking at, you have to think about this also. These structures also, how they are compatible with that. So that is also a necessity whenever you are extending. So Z as a group, whenever you are looking at the polynomial equation from this algebra we are looking at, still with integers, integer coefficients, you will be in trouble. For example, ax plus b equals 0. That is known as a linear equation, am I right? Polynomial. So try to find out, given a and b from z, it's a group structure with all such things. Then try to solve out for x. Will you succeed? Will you always get a solution inside? Yes or no? Can you expect?
No.
Yeah, no. Because obviously you have to extend now, right? Provided I may just assume that a not equal to 0 for non-triviality. So you have to go for what? The ideal solution is going to be minus b by a concept. So minus b by a will say something from additive inverse of the product of b and 1 by a minus 1 by a. Just try that. So minus b by a you will get. So such a thing, whenever you are looking for, rationals are coming into your, jumping into your world. So this further needs more and more better way of extensions, and you will reach at Q. So these extensions are really important in analyzing the things. So once you are analyzing all these kind of fellows inside, that is what are Qs. So from the naturals to the Z to Q, it was highly necessary to move on. So what are Qs or the set of rationals? How will you define properly?
Set
This
of all
consists of
P such that
quotients.
Q not
Yeah,
equal to 0.
yeah, sure. P by Q forms you can say, but you
Q
are
not.
P and Q should be in Z as well as Q is away from
And GCD
0. Yeah, fine. All such things are well known for us. So still, if you can work with that, structure is with you because Q extended addition for all such fellows. I mean, said already we are having. So Q also you have to do all such things. Multiplication is also coming along the way. So you have to define your multiplication or extend your notions from Z, the addition and multiplication appropriately to Q. These are the high school days we were used to do. And properly the relationship, I mean, the order relations, whenever you are looking, that also very cunningly you have to extend to Q. Are you getting me? Whenever natural numbers are there, from the natural numbers you have lifted to whole numbers lifted to integers, now integers lifted to Q. So Q under addition, multiplication and less than. So all such, see, whenever you must, I mean, I'm just overriding the things, but I don't have time to look at the fundamentals on that side, because n plus dot less than, if I am discussing, no zero is there. Whenever you are working on whole number, zero is adjoined with this fellow. Whenever you are adjoining zero, you should know how zero behaves with plus dot as well as less than. Am I right? So that is the right extensions. So W, if you are looking at, whole numbers are available to you. So that whole numbers, actually you are switching over to Z or adjoining some more members as the I mean mirror images of integers, -1, -2, etc. There you should be very careful how the addition is better way you are extended, multiplication you extended, and the order relation also. So such things you have to say again, or that just merely you are adjoining and making a bigger set is not good enough. You have to keep your structures well. So on that way you are trying to look at, as you know what are rational numbers, they are P by Q forms, but with appropriate extensions of addition, multiplication and order is also taken into care. So whenever you are reaching at this fellow, this not merely whenever you are working in Z, you used to call that, I mean, a petty name is there, just rings, because two operations, they are compatible to each other. That you know, even from graduate level. Now, whenever you are switching over to Q, what will happen? Q is not merely a set, it is a ring under addition as well as multiplication, and order is also there. So it is an ordered field, I can say. Is it an ordered field? Q. Hello? What do you mean by an ordered field? Yeah, what do you mean by an ordered field? Can somebody say? You have to think. Yeah, something more. Yeah. You have a field structure, multiplication. Somebody is trying to say.
Multiplicative inverse. Every element has multiplicative inverse.
Yeah, every non-zero element. Am I right? Because addition already defined. So 0 you have to avoid. So every non-zero, 0 means it's an additive identity, right? It exists. After that, you have to look for all other fellows that satisfy multiplicative inverse. So it becomes, up to this part, you will get a field. So what do you mean by an ordered field? Can you just explain to me? Your answer is fine. Field is there, that is fine. So the first experience with our field is something as Q under addition as well as multiplication, fine. But I'm using ordered also. Can you just guess me what is an ordered structure on that? This is a field, order is a relation. Relation means any R and S you can just relate like this, R less than S or something like that. In fact, you have a trichotomy here also. Right? You might have been observed this in real number system, but real number system comes last. Just before that, so many, on the way you will meet all these guys. Then only you will understand what exactly R works with analysis well. R is the group whenever you are saying something like that. So is trichotomy holds on Q? If I'm asking like that, order means a relation. Relation means it's a pairing of RS, whatever it may. So two members, R and S. Can you say this? R less than S or R equals S or R greater than S? Always? I mean with exclusive or. Is it true for Q also?
Yes, sir.
Yes.
Is it transitive, the relation? Trichotomy holds. Even with natural numbers, you can ask all such questions. Is there a notion with, see, that is what I am trying to say, or no, don't look at simply the set, look at the structures also. You have to learn a lot then. N plus dot less than, if I am talking about, can you say something about this order on this? That question is there also. Whenever you are looking at M and N are natural numbers, this is true? Is it visible what I am writing? Is it okay? Hello?
Yes, sir.
Basically, I can't see the board while I'm presenting. That's what I'm asking. I'm not seeing anybody, you. So you have to say if there is some problem is there. So this is what is usually called trichotomy, right? One of the things and exactly one. Is it holding for N, the system N?
Yes.
Yeah. Transitivity also holds well. I mean, M less than N and N is less than P, automatically M less than P. So all such things. So these structures also carrying whenever you are adjoining new elements. That is what I am saying by the term compatibility. Compatible structures. So go up to this, the field Q. Q have an ordered structure. That is, ordering is given. Trichotomy, you can check it is there. And transitivity is also there. But I am saying it is an ordered field. Field is a concept. Ordering is another concept. How will you connect them? Simply staying order plus field? Or whether it has to do with something? Everywhere it is there. You remember that. See, whenever you are saying Q is a field, for example, somebody said that addition wells behaving, it's a commutative group, non-zero elements has again forming a group. Then these two operations, addition as well as multiplication, they are interrelating well. They are compatible. I have to use the word compatible. They are not misbehaving. That is what it means. Which means you take two real, I'm not in real, I'm in rationals. So I can add them because of additive structure. I can add them and multiply with the set. What should be the whole output? You used to write very easily. Xz plus what?
Y3.
Yz. Then what you are trying to say? Compatibility. Because see, addition was there, multiplication was there. So first add, then multiply. That will be same as first multiply, then add. Am I right or not?
Distributive property.
Yeah, exactly. It's called distributivity property. But what exactly internally it says, that is what I'm trying to say. Am I right? Whenever you are saying that Q has distributive property, even said, it just says how your two operations are supplied, how that two operations are, behaving each other, one another, in the sense that x plus y, you add 2, then multiply, that is going to be same as multiply first and then add. So this concept, left or right, is commutativity kind of things you have to talk about, but that's also true. So that is what I mean by compatible structures. Q is set up, then addition behaves well. Behaves well means there also a structure. You should be aligned with that setup, and multiplication also should be like that. Finally, you are talking about order structure, whether that is also ordering is coming from this relation. So my question was something like this. You have this, up to this you have some part, or the field one. Then you have less than. So what do you mean by this is giving you the order? So ordered field, whenever you are using the terminology, some structure, some kind of compatibility with these structures you are expecting. Then only you can say, see, you have already defined addition and multiplication. How this addition behaves with less than has to be pronounced, which means suppose x and y are rationals and x less than y, can you say that addition behaves well? How will you do that? x plus z and y plus z, a quantity with z from Q, you try it out. Will it obey like this?
Yes.
Yeah. So that is what I am trying, the compatibility. It is holding. So and addition gives well nice structure with, it won't be mischievous with the order. Some order you had given, that order is or relation is respecting well, or addition and as well as multiplication also. You try to do x less than y, then try with a z, again a rational. Can you say something about xz and yz? Then you are trying to say that how multiplication behaves with order. What you can say? Are they doing well with the order?
Yeah, less than.
Yeah. It
Yes.
depends on Z. Yeah. See, a trichotomy is there. You can give order. You can give positive elements as well as negative elements. Am I right? Yes or no? Because comparison actually comes from that. Positivity, zeroness, connected well, and you can compare each other. So if you are working with a positive element Z, that respects. Am I right?
Yes.
If
Yes.
your Z is the other hand, you need that. Geometrically also you need that, because all these number system developed from the very practical point of view, and you're realizing in geometrically also. Geometrically as well as, I'm not talking anything till time with geometry, I have to come along with that, because groups are always the best models for geometry. So Z, whenever you are having a rational number, if it is positive, it makes sense with the order and comparison with the trichotomy and all. So xz less than yz, provided z is positive, as well as otherwise it has to behave the other way if this has to be reversed. Even you can talk about multiplicative inverses too. Am I right? Whenever you are having x less than y, what can you talk about the reciprocals of the fellows in general?
1 by x greater than 1 by y.
Yeah, such kind of things you need. This is, see, whenever I am simply asking what is the compatibility, this is the notion. Already a set is given, so many attributes, something like plus, binary operations, maybe order relations, some other kind of things. All the attributes makes the system bigger and bigger, maybe from algebra, maybe from geometry, maybe from topology, or from functional analysis or vector space structure, wherever it may. But attributes may be bigger and bigger later, depending on your things. So, but compatibility, whenever you're using or clipping two terms together, even ordering or field, clipping together, remember that they should do something in common. So you may suspect that it is reverses, that reversal is highly in need. Otherwise, you won't get the expected outputs from the system. Why real numbers are constructed, why rationals are constructed. After all of them started with, well, measurements from the physics point of view. Am I right? In that sense, no part of, I mean, even knowledge is an island, even mathematics also, not only algebra and analysis, all the parts are not sitting alone. You have to club each other. Disciplines also, now it's almost clear in this pandemic era, you are again finding it out. Without technology, you can't do even to talk like this. So everything should be clubbed well and interdisciplinary well, but that should be compatible. It won't mismatching. That is what I mean. Are you getting me or not? Yes or no?
Yes, sir.
Yeah. So once this goes in this direction, let me ask a little bit more. You have a compatible structure, an ordered field, a field with an ordered structure behaving well with that. But then why you are going further extensions? This is a group, this is a ring, this is a field, this is an ordered field. Fine, fine. So many things good. You can even represent geometrically. Geometrically, how will you represent all such things? That is physics you can depend upon. Physics only helped you to talk about all such things. Especially you are giving it just a piece of thread, for example, or a line segment, I can say. You can try to measure how far, how much length it is. So this is the practical way of thinking from the physicist point of view. So what you will try to say that you will make a unit to measure, that is one. So naturally from our algebraic system, we'll switch over to this whenever it is needed. In the old days of development, you will mark 0 here, and this is the 1 unit. Using that 1 unit, you measure it again, you extend it through 2, 3, 4 like that. So the measuring the lengths, line segments will give you a lot. Later, you can go for further extensions, not only with the elongated along the line, straight line. So this will be our high school level, that way of thought. So all the integers you can mark it like this, right, with the reversal, whatever it may. But then the question, see, you are elongating a natural numbers, if the bound is going to be an unbounded fellow, we will say later. Arbitrarily big natural numbers exist. Such things used to say. So it further extends like this. So you used to say that geometry is also, see, q plus dot less than is an ordered field whenever I'm using. It is an algebraic way of talk or algebraic discussion till time. But if I'm just trying to use it for measurement from the applied side or commensurable kind of things, I will start with a unit. And with that unit, I can just measure the whole length of this board, whatever you are seeing. It may be millimeter, centimeter, or your pen or your finger or whatever, your foot or anything. So once you have selected a good measurement for unit, you will try to understand it geometrically. So algebraically is also you are doing something. 0, the additive identity is placed somewhere, then unit, then 2, all the integers on the right side with some understanding with the ordering you will keep it up. So it behaves well. That is what again compatibility. See, this is from the algebra level. This is in the geometrical level. So geometry actually gives you some notion of a straight line. I mean, the simplest one, that's what all. But you can't measure a straight line. Its pieces, the finite pieces you can look at. That is a finite world usually starts up, then goes for infinite. So you measure it, the length of the line segments, make a unit starting beginning with the measurements, use that. Your measurement unit is fine, then you will give all 2, 3 or the right jumps, the usual LKG ways or primary ways, reversal, additive inverses, multiplication also structured here. So all the properties in algebra that is encoded in this geometric language here. Whenever you are saying 1 plus 1 is 2, a simple fact in Q, which is a closure. But here 1, again a 1 unit will give you 2. That jump practically do a lot of things. Actually, as a compatibility of the right jumps, that is our usual high school standard, right? High school practice. So all such things are compatible. From one field to another field you are jumping. But that jumping is not mischievous. It's accordance with the rules. So you can see an algebraic objects here, you can reflect here on the geometrical level, it says a lot. Sometimes geometry may be easier, sometimes algebra may be easier. Wherever you want, you switch over and do the things. But algebra, whenever you are looking, algebra is too simple in some sense. Beginning is better from algebra. But once you are touching groups, our topic is again groups. It has to say something more on that, even at this part. Whenever you are trying to realize them as a group and you are trying to look at analysis, you have to say a little bit away from algebra, which means infinitesimal process you have to look at now. So once again, let me ask, see, rational numbers is it enough? A simple question. Is rational numbers are enough to measure your line segments in geometry? Yes or no?
Sir, repeat, please.
I will repeat. See, when a line segment is given for you, you can measure it, the length. Can you use just rational number system? I have all rational number system, it's a field. So using rational numbers, can I just measure all lengths of, all possible lengths of, all possible line segments length? Is it possible? If I know only measurement, my measurement tool is only rational numbers. Can I measure all line segments? Line segments are finite, right? A piece of finite path.
No, sir. Density
No.
property.
I have not stated anything about density, but yeah, density property you have to say later. But obviously there is some problem. What is the real problem? At least we are experienced. See, this is another avatar of question or rephrased question of, is there exists something as a measurement which is attached with the irrationals? Am I right or not? You stated something about density, that I can obviously use it. But what is happening here? See, density and density says in betweenness. Am I right or not? Whenever you are taking two rationals, in between what it happens, such questions are coming out. But if you are already inside Q, any two rational numbers, again in between another rational number is there. You make me remember that. That is a very fine thing which you are missing whenever you are switching from Z to Q. May I know your name, please? Hello? Hello, is it audible?
Yes, sir.
Yeah, what's your good name, please?
Sir, Sudarshan Roy.
Yeah, where are you from?
Sir, West Bengal.
Yeah, good, very good. So actually, whenever I am switching over from Z to Q, whenever I am looking at, see, natural number to Z, whenever you are looking at, see, natural numbers are having malordering property. Z, you will miss it. Am I right?
Yes, sir.
But still, immediate successor and predecessors are there, right?
Yes, sir.
But whenever you are moving to Q, what happens? Will you get as immediate successor and predecessor? Just for Sudarshan, I stated, but everybody can think about that. What do you mean by? You can guess what is an immediate predecessor. See, after 1, next to 2, 2, then 3, -1 to 0, something like that. In between is a vacuum. So that is what I mean by immediate predecessor as well as successors. That is one of the discreteness is always coupled with that. Integers are having. Rationals, once you are moving, you will miss that. In fact, what Sudarshan says that something density, some kind of thing. Two rationals R and S is given, in between R plus S by 2 in these directions you can give it. That is what you mean, right? By density? Am I right or not?
Yes, sir. Yes.
Yeah, very good. So once you are doing that, you will be fine. But see that my question, I will make it one more step forward. You have rational, see, you have the geometrical object real line. Real line I can't call now, but at least straight line. That's a geometrical fact. So straight line, if I'm giving it for you, you have marked your identity here, 1 here, 2 here, 3 here, everywhere, -1, -2, etc. Everything is fine. So then gives all these, as you said, half, 1 by 3, 1 by 2, all such things. Translate it, you will be getting on the right hand side every right fellow what you have done here, and reversal also. So it is completely, as you said, a density I am seeing. Fine, very good. Everywhere it is filled up. Something like oxygen molecules are dense in our atmosphere in the classroom. Something like that. Very good. But are there any gaps in between? If you are asking, if you are giving me the answer as density, density is fine. So even after 0, I can't say, or you can't say that which is the next rational number. Am I right or not? Is this question answerable? Next means ordering comes. You are working on Q. Plus is there, dot is there, less than is there. So after 0, you can't say which is the next rational number is. Am I right or not? Are
Right.
you? Yeah. Yeah. Why is it so? If you are taking any epsilon, you can go for epsilon by 2. Epsilon is a rational number. That's all. So many you can have. Abundance of these fellows will object you to say that is good. Still, as Sudarshan says, I may ask this who answered me, right? Can I know your name also, please?
Sir, Anjali.
Yeah, you are from?
I'm from Mogeri Government College.
Very good. You are from Kerala. He is from Bengal. Very fine. They are having similarities or equivalent things, so many. So anyway, good. So whenever you are looking at a member, two members, you can have density as he says, but next to that you can't say that. Next to that you can say that it is, you are missing something while moving from Z to Q. Fine, but that gives a lot. But still there is a question, gap is there. In fact, are you feeling any gap in this line? If I am just adjoining all the rationals everywhere, that is what is meant by measuring using 1. So can you fill all, if I know about all rationals, and if I am filling it with this structure, I mean this geometrical straight line, everywhere where it is 1 by 2, m by n. M by n means what should I do? The whole thing n I will divide it, and the one piece into n parts, and 1 unit I will divide into n pieces, and that is what 1 by 2 is, 1 by 3 is. Yeah. So m times I am shifting, you will get that. Any natural number is an integer multiple of 1. Am I right?
Yes, yes, sir.
Yeah. Whenever you are saying Anjali like that, it actually says a lot. It is nothing other than the Archimedean property. Am I right?
Yes.
Yeah. You can cross over any rational number. Arbitrarily big natural number exists.
Yes.
So such a thing, that let it be there. So with Anjali's help, I was trying to say that this question is raised now. Is Q, it is an ordered field, fine. Now the question is another one, is it an Archimedean field? Then we will come back to my question again. See, my timing is up to 12:30, am I right? Shabana? Or anybody from the department?
Yes, sir.
Yes, sir.
Yeah, fine. So Q is an ordered field. Under addition, multiplication with this, fine. So Anjali had given me something as an Archimedean notion. So she said something. She nodded me that arbitrarily big things exist with naturals, because any rational number beyond that you can go. Any arbitrary, how will you state it? Let me, I am expecting it from you, because all of you know what is a notion of Archimedean. Anybody understood what exactly is an Archimedean? So a field, an ordered field. So look at R, not R. Simply on Q you are looking, remember that. Don't simply jump over to R. Look at R, analyze R, go down to R. What you are missing, the lower structures, fill it, then come with R, then go further. That is the way you should do. So all the structures you should know previous. So sometimes you are simply assuming like Bartle. Now, so many people are using Bartle as the text for this one and Rudin as the next text for MSc. Fine. But they are viewing all the things from R. But before that, what happened? That should be known. That you have to work out and what is missing there. So Q is also a field. It is an ordered field. So my question is Q is Archimedean? I hope Anjali can try that, or anybody from your gang can try that, or Sudarshan can try that. Can you state it, what I mean by that? I am asking a question. Any fool can ask question. Answering is difficult, right? So I am taking that freedom, don't worry. So what should be the meaning of an Archimedean field? In an ordered structure, you can talk this, but what do you mean by that? Can somebody explain? Either statement. See, I'm not expecting the full statement, pakka statement like something from the text and omitting it out. I don't want that. What it says, that is enough for me. For the entire discussion, it is enough for me. Then make it rigorous. That's all. So, can somebody mimic that? What it says? If I want, what do you mean by, see, you know what about R? R under addition, multiplication, less than. This is also an ordered field. Will you object it or with me? Q is an ordered field. R is also an ordered field. So what about the second statement? Is it also true? Is R with these structures is an ordered field? Hello?
Sir, our ordered field alle.
I am simply asking, is it or not? You can have all freedom to say yes or no. I'm not teaching you, or you are discussing. But you should be, I mean, away from the fear, whether it is wrong or it's a ordered field. How to check? Addition as well as multiplication behaves exactly well with these adjoint fellows which are not rationals. That's all. Already rationals are there. So something more, you are adjoining with the rationals and you are making bigger and bigger things. Bigger set is made it into a bigger one, that is R. At that adjointification, still order structure is preserved well. That is what is an ordered field. So as you said, it is correct. It's an ordered field. Is it an Archimedean field, ordered field? Will it Archimedean property holds on R? That is the core question. See, I am not talking in Malayalam, basically because others are there. So, but you can think about those who are in Malayalam or in Kerala or Bengal or wherever it may. No problem. You can think it's a universal language, right? It's a mathematical English only. I'm using it. So, Archimedean property, whether it holds for R. See, even if somebody is saying in replying it in Malayalam, no problem.
Archimedean property hold ചെയ്യൂലേ ആറിനു
ചെയ്യും. Yeah, exactly, it holds. It says that it holds. So what is the statement? What it says? Can you spend a split of time for that? പറയുന്നത് ആരാണ്?
അഞ്ജലി.
Anjali, can you just say what exactly meant by Archimedean property on R? If you remember well, just the idea is enough. What do you mean by that?
ഏത് രണ്ട് റിയൽ നമ്പേഴ്സ് എടുത്തു കഴിഞ്ഞാലും
Yeah.
അതിന്റെ ഇടക്ക് നമുക്ക് അങ്ങനെയാണോ സാർ? കറക്റ്റ് അറിയില്ല.
Don't worry about. Why you are frivolous? You are doing very best. Then why you have to worry about? In between something, as Sudarshan said, in between you are trying to say something. It says that it's a density, right? Something more is true. Something more is true. Maybe in degree level you will study in this way, Archimedean property. Maybe a reformed way in Rudin also says, but all are same in the sense that that's why we are getting some idea that should be the foundation should be very clean. So Archimedean property, what is the importance and what it does? That is most important. In my opinion, it simply says what? Your unit is very perfect for measurement. I will try to explain that. Have you observed in that way? Have anybody observed in that way? See, you are measuring using your all measurement method starts from natural numbers. So natural numbers started with 1 unit, then 2. So what is 3? If somebody is asking, my answer should be what? Can you guess, Anjali? 3 times 1 added. So 3-fold of 1. Am I right?
Yes. Yes,
yeah.
Sir.
So it means that 3 times 1, the multiplication comes into the picture. 3 times the unit. Unit means it comes from physics. Whenever you are a measurement, absolute unit or apparent unit, whatever it may. So you need a unit that should be, theoretically means you are always working with absolute things. So 1 unit is taken, that unit, how many times? An integer multiple, that is giving 3. Am I right?
Yes.
They are nothing other than that natural numbers. So arbitrarily large natural number exists that you have to say somehow. So in the real number system, how you proceeded in the Bartil or somewhere is usual practice is that you take any real number, beyond that some natural number exists. Am I right or not?
Yes.
This is
Yes.
the first primary days of Archimedean property. For every x, whatever may be the x you select here, beyond that there exists some n, which strictly exceeds that x. Or you can say something like that. There is nothing wrong in it. So x less than or equal to n. It covers. So what is your x? See, using 1, again, whenever you are realizing 1 means usual length. This is a meter scale, is a tape or whatever it may, or feet or your finger. So many times will give integer multiples. So that will take you a long way. Now you try to measure the distance from here to moon. What will happen? Even with millimeter, your unit is 1 millimeter, you can measure it. Am I right?
Yes.
After certain time, certainly a finite stage, you will cover that. So that is what it says. Any distance as a real entity that can be covered by a finite steps, I mean of 1 folded n times. Am I right now?
Yes, sir.
That is the whole theory what you have to convey from Archimedean property, nothing more. Any other avatar you read it, but that is the same thing. You try to understand it, either from Rudin, the higher level, or this level. Okay, both will be giving same thing. So I think it conveys to everybody. So natural, it says in another way, arbitrarily large natural numbers exist. Whatever may be the real number, you have beyond that. See, these questions I'm jumping now because of Anjali. And of course, a little bit of notions of Sudarshan. If somebody is also joining with us, we can also say something more also. That's what I'm saying. You have to come in and interact. Then only I can come up. Otherwise, I can't do. So anyway, this is R. But I am working in Q. It is a subpart. So Q plus dot less than is worked. So there I am asking the same question. So how can I answer that? I can ask the question here. System is rational numbers. So how will you ask the Archimedean property holds here? Rational numbers are there. So if it is Archimedean means, what do you mean by that? That question can you frame? That's all. Our working is only in Q. Take any Y. Can you just say something? Is there exist? If Y is any rational number, maybe you can take positive. Measurement always taken positive. So I will try to say, if 0 less than Y less than, Y is available in U in Q. Y is a non-negative rational number. Then if I am saying that there exists some M in N, M means try to understand 1 M times added. That is Q, it will allows you. Q is a field, 1 is available, your measurement unit is available. So is there exist M? Can you complete such that? Can try? Can you try, Anjali? Such
Sir,
that?
sir.
Yeah, the idea is something like that. You have some notion about Archimedean property on R, right? Archimedean property on R can be stated like this. Suppose Y is a real number, which is greater than 0, a non-negative number, just for measurement, which is available in R. That's only what I'm saying. Then your statement was there exists some M in N. Instead of small n, I'm writing M, such that Y, after Y you should go with N, with M. That's all. M or N, whatever it means. Or M less than or equal to M. This is what is the Archimedean property in R. Right?
Yes.
So can you make a statement here? Y is a non-negative quantity, but now rationals only. Then can you say the same thing? Is there exist some natural number for you? That natural number should what? It should do what? Greater than or equal to?
Y.
Y. That's all. Everybody sounds very good. This is the Archimedean property. The question poses well. See, many times answer or theory is not doing well. You should ask questions. We should think, not I or you. There is no difference between fundamentally me and yourself. I am presenting it now, that's all. You can also take the same lot once you are ready. So once you have the same question, you take any non-negative rational number, is there a possibility of getting a M which is away or which crosses your Y? Is it true? If it is true, it is an Archimedean field. See, basically, I wanted to look at R as a group and I want to do analysis, but it will take more time. So, if you are, but we are just doing something on a basic part now. I wanted to do analysis on that, but it will take some more time. So, I need some more time. So, maybe we are, fastening our discussion, you will get more things. So, is it true or not? Can somebody prove this? Are you brave enough to prove this? Any MSc, any BSc student, some hints can you give? Quite simple. See, we have proved something on real numbers. So don't believe that nothing happens on downstairs. You don't need anything. Even in Q it works. See, it's quite simple because Y is a rational number. So what you can do? Y can be written as what? An M by N form. N is away from 0. So M and N are what? All are positive. Yeah, they are integers. Natural numbers, I can assume GCD is 1. Least form I can assume M and N. So N should be greater than or equal to
0.
What? Yeah, strictly means greater than 0 or greater than or equal to 1 I can say. Am I right? Y has a form like that. Y is exactly looking like an M by N with least forms. So N should be greater than or equal to 1. So n should be greater than or equal to 1 means what? I have already stated a compatibility of the reciprocals. What is the reciprocal will do then? 1 by n
1 by n
less than or equal to
1.
1. Fine, very good. Who's answered that?
Vimal.
Yeah, good. Vimal. You are also from Mageri or?
No, I am from Malabar Christian College.
Where exactly? Malabar. Yeah, fine, good. So 1 by n less than or equal to 1. Fine. 1 by n less than or equal to 1 you are giving. You can come back to y by just multiplying m on both sides. What will be the effect? M by n less than or equal to m. Right? Just because m is a positive quantity. M is a positive quantity. If I am multiplying both sides of this inequality, I will be getting, it retains the inequality. That is what compatibility of addition with a less than. So m by n less than or equal to m. Is it enough? What is m by n?
M by
So
n, sir.
y is less than or equal to m. You got it, right? Very simple, much simpler than real number system. So all rational numbers are behaving exactly like real numbers in this Archimedean style. So Archimedean property not only holds on R, in the lower field also it works well. So but it says, you should understand that Archimedean property actually gives this kind of measurement. Okay, is it clear for everybody? But it says another way also. You can actually prove the following. That I am leaving it as an exercise for you. Suppose you have a rational number x, which is a non-negative value. So if I am saying that there exists a natural number n such that 1 by n is less than x, is it true? This usually we used to see in exercises or corollaries or so many things in real number system. You have to be a little bit quicker, otherwise you fastening the things only will make it to you within 10 or 15 minutes. So I want to say a lot about that. So is it true? Can you do this as an exercise?
Yes, sir.
It's going to be true. It actually says both ends. N is arbitrarily large. Arbitrarily large n exists, even with rationals. So reciprocals of naturals, they are harmonics. 1 by n's, they are arbitrarily small. Am I right or not? 1 by n's coming nearer and nearer to where? As n is becoming large, what happens?
0.
Near to 0. Yeah, 0. In the number line, you look at your experience. 0 is there, 1, 2, 3 is there. Then natural numbers are going away from you, which means arbitrarily large. I mean any y anywhere as m by n is given, I can find obviously some m or p by q here. I can find an m which exceeds that. That is Archimedean. On the other hand, it says you go for 1 by n's, it's coming down, and you may get this 1 by n's nearer and nearer to 0. So once you are understanding infinity, you will understand 0 and conversely. Am I right? Nearing towards. That notion comes not from algebra, as I said. It comes from a limit process. A limit process can be done only in where? Analysis tools. Am I right? That was the beginning. I have to come back to that. So a limiting process will be available in analysis that you can use it in algebraic style, which is an ordered field here. So whenever I am Archimedean property, if I am stating that arbitrarily large natural number exists to cover the measurement, on the other hand, I can say infinitely small reciprocals are also existing towards 0. But these two concepts actually takes you away from algebra. The notion of convergence, the notion of sequences. The first sequences or the explicit examples of sequences are natural numbers. Natural numbers in inbuilt sequence is there. That property you are using a function and giving to a setup. Yes. So you're getting a sequence as a function from natural numbers to some set. Am I right? Yes or no? So once you have sequences, you can talk about all other kinds of things, limiting and all other operations. So limiting operations are well versed for you. You can talk about analysis on that. So Q is a field. Q is something like this. We will come back. It's an Archimedean field. So my question again in this style now, Q plus dot this fellow is an Archimedean field. Everybody accepts that or not? Yes or no?
Yes, sir.
Yeah. So now you already studied something, an extension for this fellow. How you are extending? This is also you are saying an Archimedean field. But what I can say is, yeah, please, you want to ask something?
No.
Yeah, you can ask. See, any field you take, any ordered field. This is a simple question. F is any ordered field, as I used the whole terminology as I stated before. So in any field, whatever may be an abstract field, it always has a copy of Q. Am I right or not? Any field, ordered field, which is having some addition, multiplication and less than with U, I can say that I have a copy of Q. Q means rationals, rational members in this, which also sits side. It's quite simple to use because any ordered field means you have one. Am I right? Field always having 0 and 1. 0 is the additive identity. 1 stands for multiplicative identity. So that n-fold sum will give all natural numbers. Am I right?
Yes.
Yeah. So all natural numbers are available in F with its order and multiplication, etc. like that. A further level, m by n's you can define. Quotients. I mean product you can give. Once m is there, mn you can define, inversion you can define, m by n you can define. So everything, any field, any ordered field, you can think about it taking care of what? A copy of Q, provided you are working in ordered field. So always, so it is the smallest Archimedean field you have to start up. Are you getting me? Q is the smallest Archimedean field that you can start. There are big fields containing this. One is R. But can you just state a field in between? Why? There are two questions now. One, how will you move from Q to R? Why you have to move? That is one question. That is analysis will come then. Obviously, the second question is, are there any fields in between Q and R? Either BSc students or MSc students can answer. MSc students definitely should know that, no doubt in it. If you are just thinking about two questions, you have to answer within time. Then only we can wind up in the right time.
Q of root 2.
Yeah. Are you doing MSc?
Yes.
You mean this?
Yes.
Yeah. So what you are doing? Your youngsters, I mean BSc students has to be understood what this is. So what it consists of? So to Q, you have to adjoin root 2 he says. So in the problem, in two ways it comes out. Root 2 you have to say. Root 2 is not going to be in Q, that should be known. So some fellow which is called root 2, which is named as root 2 is not available in Q. You are trying to adjoin. Am I right? Vimal is talking about or no?
No, sir. Akhilesh.
From the sound. Who?
Akhilesh.
Yeah, food, good. So, Q root 2. What do you mean by that? Is it something rational multiples and additions blended together?
Yes, sir. A plus B
Yeah.
root 2 type.
Yeah, exactly. I may write R plus S root 2
Yes.
because R and S may be more compatible, right? They are in Q or not?
So
Yes.
Gaussian set it.
Okay. Hello? Is it right or not? What you are expecting, is it in the right way or not? That's what I'm asking. Sudarshan also say something. Yeah.
Sir, is it Gaussian set?
That you have to check. So we'll come back to that if you need it. So basically you need, see, you are doing this extension for what purpose? Because question will tell about that. So R and S are rational numbers. Using rational numbers, in rational numbers you have addition and multiplication. It will be blended finally with your new object which is going to be called as root 2, which you are believing that not in Q. So these kind of fellows, am I right? R and S are in Q. This may be because root 2 is there means minus root 2 also should be there. Inverse is also well behaving. So all such things should include Q also. Definitely you can make S is 0. So all such things can be done. So these kind of things will give you an extension, fine. But how many extensions you need to reach at R then? Can any guess? Only merely root 2?
No, infinite.
Infinite ways of root 2, root 3. In some sense you are going beyond the structure of algebra. You are at the structure of linear spaces, good extensions, and if it is a simple question like R over Q is infinite dimensional or not, that answers in some way. So anyway, all root 3, you can't make up root 3 using root 2. I mean using these linearities. So you have to adjoin all infinite level of. So many fields, so many fellows like this you have to extend. Okay, let it be there before saying further, because I have to come back to algebra within 5 or 10 minutes I have left out. So see, what is root 2 then? That is why I asked, see, he has also joined now. I mean, at least he's also coming up. So Darshan, the root 2, that is what we will come back with that. Rational numbers, using rational numbers, it's an Archimedean field. It's an Archimedean ordered field. Some more adjoint field, you have stated something about that. Even so many fellows, and finally you are emerging with R. So how will you are reaching from Q to R? That is the fundamental question. How you are moving? Can you have an answer? Root 2 is not a rational number. That is easily everybody can prove. Then how you are capturing root 2 from Q? Then only the rational multiples and additions.
0 plus 1 Q, 1 root 2.
0 plus 1 root 2. But what is root 2 then? Is there exist? So you once again think about from algebra side, our group side or field side, and the straight line side. And I have asked you, can you measure always the line segments using rationals? You are going to get no. Because there exists some lengths, at least some line segments, whose lengths are not going to be rationals. You remember your days once again, you will get that. This may be 0, 1, 2, 3, etc. The representation, all 1 by n's and the translate schemes, rational schemes, Archimedean field came. So where root 2 you will place? Root 2 is not available here, something adjoint, fine, extra. That root 2 where will you place here? From the geometry also you can think about. Where I have to place? So that is what I am asking. If I am making a line segment, something like this, see, this is one. It's quite simple. You can, anybody can guess. In the plane, if I am drawing this is 1 unit, something will happen like that. Hopefully you remember now, right? Why I had drawn this? Can somebody guess? Yeah, exactly. You will get the position root 2. So if I am taking a length or an interval AB, Sudarshan, AB, I can't measure using rationals because it's root 2. Root 2 comes naturally something like this. So it is not
Pythagorean
measurable.
function.
Hello? Tell me. Yeah, Pythagoras theorem is helping you, but Pythagoras theorem comes from linear space structure. Am I right? Yes or no?
Yes, sir.
Yeah, because Pythagoras, why you are using Pythagoras theorem here? In a triangle, something happens like this. So a perpendicularity comes. Perpendicularity comes from the inner product. Am I right? So R is an inner product space. R2 is also inner product space. So product inner product space means geometrically you can say something about Pythagoras theorem. So structure is again coming. So R in this case. So that is about R. About Q I'm looking about. So Q is inability. He has the inability to catch or capture all line segments from the practical point of view. You are adjoining root 2. So finally, what is root 2? How will you capture? This is the geometrical evidence. So how will you capture root 2 from Q? Anyway, will your algebra will do or something I have to do? You have to be quick, otherwise it's already 1:25 or something, 1 hours and 25, some 5 minutes you missed also. Just stand in Q and can you catch hold of root 2? That's what my question is.
0 of the polynomial x square minus 2.
Yeah, that is the way you are saying x square equals 2 or x square minus 2 equals 0. You are trying to solve it. Is it solvable in Q? It is not solvable. Right?
Yes,
So
sir.
So can you guess how to capture root 2 from standing itself in rationals? Is there a way? Just think about, I mean, if you are not remembering the whole scenery, MSc students can definitely say something. You should say, because you use density in a much, much better way. Rational numbers, you said in betweenness rational number is there. In the real number system, any number can be captured from rationals. They are handy from rationals. Rationals are enumerable. So how will you say that? Topology or algebra or analysis, anything you can use it. Not only density you are using, a little bit more. You know about closures, MSc students. What is Q closure?
Algebraic number.
Yeah, Q closure, yeah. Q closure is, do you remember anybody?
Algebraic numbers
R.
or C.
Okay, R I am taking. Q is there if you know. From Q, if I am taking all something more with irrationals, I am taking it out basically. Fill it with irrationals, they'll fill up and I can make any measurement that is a geometry. Fine. From this point of view, when geometrical or more general topological way, you can ask this question. In R, Q is sitting inside, Q is fine, Q is the enumerable set, it is having its own density, but R is a field, it is an Archimedean field, it's a very big field now, which includes all the extensions like this, root 2, root 3, everything like that. It actually solves all the, up to some extension. Not all quadratic polynomials are solved in R, that you know. Obviously, for C you have to go. Algebraically or the other thing you have to check about. So it's a field, just a field, it's an ordered field, it's an Archimedean field, order is there, but you can't simply jump over to C because you can't have any order there. So on Q, if you are working, I can simply say that Q closure, what is the meaning of that? A countable dense subset exists in R. How will you say that? How will you pronounce that in R? You have no terminology to use that? Think about. If I'm saying that, just use sequences, you will get that. They are all metric spaces at least. Or you can have, see, whenever, why you are saying that the sequence converges to somewhere? You are having the notion of distance, right? So all these things you have to read in one hand. How to capture root 2 from Q? Using sequences you can say. It's quite simple. What is root 2 in decimal expansion? You write down root 2. How many digits should be there? Numerals should be, have to use 1 point, etc., etc. I have to write, right?
1.41.
Yeah, maybe up to 10 decimals you can write down, or 100 decimals you can write. Will it repeat?
Yes. 41.
Will it repeat? Means is it a recurring decimal or not?
No.
No.
No, complete irregular is there. So if you are remembering well, see, okay, you can write down something like any root 2 like this. See, root 2, if I am remembering something like that, you can write down 141, write like that. Any calculator will give you. It's not recurring. So which means, suppose I am working with x1 as 1, x2 as 1.4, x3 as 1.41. You are getting a sequence, am I right? Yes or no?
Yes, sir.
Will it be converging to somewhere? Do you just think where it converges? In this strategy where it's tending to converge, what I have done here, 1 point the first decimal, 1 point second decimal also included, third decimal also included. So ultimately, using some algorithm, I am trying it out, and this sequence has to go somewhere. I am saying where it should be, definitely. Because I am using x1, x2, x3, x4 like that. So this xn has to converge to where ideally?
Root 2.
Root 2. But all of them are rationals, am I right?
Yes, sir.
Because they are finite decimals, not recurring. Strings of zeros only you are getting. So 1 is 1 by 1. 1.4 is 14 by 10 or whatever it may you want to write. Something like that. 141 by 100. So many things like that. So all such things. But this is a simple technique, right? So all rational from this rational side, but this is quite arbitrary. I have written very high school algebra here, but it's far-reaching effects in the sense that you can do this in any way. Whenever you are writing root 2, you can actually manufacture any sequence. See, you can start with any sequence. Can you manufacture a sequence which actually converges to root 2? Just usual question in degree usually. You can always do that. Very simple. Actually, you start with an x1. What is the speciality of square root of 2? It solves as Vimal says x square. Vimal only told you, I don't remember. X square equals 2. The solution is what? That is root 2. So whenever you are writing root 2, anything multiplied by itself has to be given as 2 as the answer. So if you are giving me an approximation x1, I will give an approximation 2 by x1 if x1 is away from 0. Am I right or not? Because this is an approximation, first level approximation, multiply with some quantity. So you said me that x1 is root 2. You may say that x1 equal 1 for example. Then I will give another assumption for you. You take 2 by x1 as my assumption. Because x1 and 2 by x1 should on multiplication give you 2. That is what you need ideally. But it is quite a raw approximations. So better to make it something a convergent notion. So I will do like this. I take an average of these fellows. That always gives you, statistics always smoothen the process. So I will just do x1 plus 2 by x1. Then I will make it half. So I am averaging. Arithmetic mean I am taking it out. You have given me a choice x1. I am just pronouncing 2 by x1. Maybe a good choice from this. I will average it. It will be a better choice for something. Right? Can I do like this? You have not noticed this? It's available everywhere, even from the old Greek. So once you start with 1, what will be x2? You think about x2 should look like how? Half of 1 plus 2 by 1. It obviously shrinks. Then find out using this x2, again you do the business. 2 by x2, it's a better approximation, definitely, no doubt in it. This is 3 by 2, it's actually 1 by 5 or something. So now put these fellows here, average it, you will be getting a much 1.41, you will get something like that. So again use it as x3, go for x4, x5 like that, the same process. So in iteration way you will give xn equals, can you guess what should be the formula, right formula? Xn minus 1 or n plus 1 I can write. So I may write to be quick. So xn plus 1 is going to be xn, start with an xn, go for 2 by xn, average it. This is increasing, this is bounded, so many things you can prove. So bounded convergence theorem will give you it converges ideally. Basically, suppose it has a limit, xn converges to x. What happens on this level? X should be equal to half of x plus 2 by x. Am I right? If x is the limit. Am I right or not? Hello?
Yes.
Yeah.
Yes.
So just to do that, this will be this LCM you have to look at. So what should be the effect of this thing? X plus 2 by x. So x square plus 2 by x. So 2x square. Yeah, it comes with 2x square here equals what? X square plus 2, which means x square equals 2. Am I right or not? So whenever such a limit exists, you should go for x square equals 2. Am I right? So this is the prescription. It's available in even Bartle, I think. So not in this way it's pictured, in some other way it's pictured as a binomial and something like that, a discriminant or something. But idea is that. So start your x1 as 1 or 2 or 3 or whatever it may, very fast way, in a very quick way, you will reach up to any number of accuracy up to root 2. Root 2 you can't write it in the full terms, definitely. It's an infinite recurrence, non-recurring decimal. I'm sorry, in the, rational number, real number. So let me, this work, you can work it anywhere, any other kind of thing, 3 also. Just you use the formula xn by xn plus 3 by xn and average it. All such things will give for xn plus 1. So all such things will come out. Anyway, don't worry about such things. So my whole aim is that you have a sequence which stands in rationals, but it converges to irrationals like root 2, root 3 and everything like that. But you can always do like that. But this process is what? Take root 2 in your number line. Then, so it is complete. You used to say that that is the difference. Q plus dot less than is an Archimedean field, or you are adjoining all these kind of things, infinite extension and a thing. This also comes here. But from Q to R, how you are moving around means you are actually taking all sequences and going towards which converges to root 2, root 3, something like that. So convergent sequences, that is the notion. All the convergent sequences make a stand inside. That is what the limit is taking inside. That is what I was asking Q and Q closure. Consider all sequences which are having the tendency to converge. What are the sequences which are tending to converge? Can you just say for me for 2 minutes? I have already taken 5 minutes more. So what are the converge? All sequences may not converge. Some special sequence only will converge. Can you just take care of such sequences? We used to say there is a speciality for convergence. You need it necessarily. Can anybody smell out? Have you heard about Cauchy? What do you mean by Cauchy sequence? Hello? Is it audible? Hello? Hello?
Yes, audible. Yes,
Yeah, yeah.
audible.
Yeah. So rationals are there, real numbers are there. Now I wanted to say that this is sitting inside, but Q is an ordered field. It's an Archimedean ordered field. This is also an Archimedean ordered field, but R is differing from Q as an ordered field. This ordered field, you say that this is a complete ordered field. This is not complete. So completion can be realized in many ways. If you are with the analysis, you go for limiting process, you go for this convergence, all possible converging sequences, then what are all they? They are going to be Cauchy sequences. See, whenever you are saying that xn converges to x, obviously what you are trying to say is xn minus x is arbitrarily small as n tends to infinity. So naturally the triangle inequality will say you that xn and xm cannot be differ much, because just split up using this limit whenever it exists, right or not? Is Anjali still there or Vimal is still there?
Yes.
They are answering. Yeah. So this idea, this goes to 0, will tempted to say that these kind of things only will converge. It's a necessity. So Cauchy sequences in our experience converges, but not always. See, for example, 1 by n's you take. Suppose you are working with 0, 1 as the set x. There also you can measure the distance between the sequences, terms of the sequences. That is given by the absolute value function. So you look at 1, 1 by 2, 1 by 3, 1 by 4 and all. 1 by n is obviously a Cauchy sequence. Am I right?
Yes.
But will it converge in this set?
No.
X is, it is 0 is excluded. Remember that.
No.
So you won't get it here. But it's having the tendency. But on the other hand, if you are using something like this, a closed thing, it will work. That is what is happening. See, Cauchiness is essential for convergence and all. But Cauchiness, see, convergence, if you want, Cauchiness is the other way. Cauchiness, if you want convergence, definitely it should be a Cauchy one. But Cauchiness necessarily may not give you what? In general convergence. It depends on the space where you are. depends on the set. Are you getting me? What I'm trying to say? If you
Yes,
have
sir.
a convergence sequence or convergence notion, nearing means distance concept. Definitely distance is given by modulus function here, xn minus x. So whenever you have a convergent fellow, Cauchiness comes very easily. But Cauchiness not always gives you the capturing limit. That limit should be included. That is what the completion is doing. So root 2 kind of things in our experience, what happened was rational sequences itself jumps out from the world of rationals. That you have to capture all the capturing of all this. So all consider all Cauchy sequences and their limits. That is ultimately you are going to give the completion algebraically. I mean order field algebraically, geometrically too. Geometrically, whenever you are talking about analysis and geometry will come. So this is an analysis part. It starts with this analysis Q to R or getting irrationals, but that is just the beginning of the story. In fact, R with its addition, if you are looking as a group, actually I wanted to spend more time on that, but no time is there. It's already late. So R on a group, you can ask all these calculus kind of questions that I'm leaving it for you to think. R is a group. R under addition is a group. Fine? Yes or no?
Yes.
Yes.
Yeah. So R under addition is a group. If I am asking is plus is a continuous operation, because I can have all this right to ask, because addition works from where? It's a binary operation. So R cross R2 R. Am I right?
Yes.
Yes or no? Yeah.
Yes.
R is having a metric structure. Distance structure is already there, given by absolute value function, given by inner product structure and topological structure or whatever it may. So R you can talk about distance, and distance means ideally give a metric structure. Usual metric, absolute value function metric, A minus B, mod A minus B. So R cross R also, this is ideally geometrically R2. There also the metric structure is there. Or you can think about product topology in general. So anyway, here also you can talk about distance. Here also you can talk about distance. So addition works as a function x comma y will be mapped onto x plus y. So as a function, this is metric, this is also a metric space. This addition, is it continuous, is sensible? Yes or no? Continuity, you can talk about topological spaces, in between topological spaces. Am I right?
Yes, sir.
Maybe, yeah, in the last moments only I am talking about higher mathematics in topology or something like that. Topology is actually coming from the algebraic side, geometry side. Geometry is very strict, a little bit relaxed one is geometry, topology. So I can ask about whether this function, as a function you are considering, is it continuous? Can you guess? Is it a continuous operation? Binary operation is continuous?
Yes.
Yeah. How can you prove? Can you quickly say why it is true? Both are metric spaces. Both R2, which is R cross R, other side R, both is with usual metric. Standard metrics are there. So how will you check easily? Very easily you can check this, because they are metric spaces, they are having the distance notion. Sequences will give you already introduced sequences. Just consider sequences here. Suppose this converges to this, that you can make sense, right? So what happens on the right hand side? Xn plus yn, they map. Where they go? Will it go to x plus y? Yes or no?
Yes.
Yeah. So if you have a function, xn converges to x in the domain side, or yn goes to, or something zn goes to z side. F of zn goes to f of z. In this case, at least metric spaces, that says that the function operation is or function is continuous. As a group, inversion is also important. So from R to R, once again I can ask any member x goes to its inverse. Inverse here means minus x. Additive inverse. Is it continuous? So inverse function. I may write I, for example, not identity, remember that. X going to x inverse. Again you can say xn converges to x minus xn converges to where? With usual absolute value function you can say that. Xn converges to x means mod xn minus xn has to go 0 as n tends to infinity. That will ensure you that minus xn goes to minus x. Am I right or not?
Yes.
Yeah. So which says what? In a group, R is a group. From that group side, if I am looking this plus as a binary operation, it is, you have to say that this is continuous. So this is a topological notion. The first one was an algebraic notion. So algebra relates with topology or analysis. Analysis and topology, it comes nearness. Continuity always says something like that. Continuity is nearing points are kept intact. Is that is the notion or not? Nearing points are keeping intact. That is what continuity means. Am I right? Your epsilon delta definition you look at, you'll get that. Go in the neighborhoods of input side, you will be again getting the distance notion once it is there. R going to R, this is the inversion. X going to its inverse. This actually xy goes to x plus y. Both are continuous functions. So continuity prevails for the group operation and it mingles with the group operation. I must conclude my session by saying that R is so rich because at least if you are considering R under group, all other structures are coming inside, but R under group as a group, abelian group as you started before, even the group operations are, once again I may use and complete, what is that? Compatible. They are doing well with the analysis structure, because this I am talking about in analysis language. Continuity is a byproduct of topology. You are saying in continuity, what is a continuous image of a connected set? It should be connected. Compact set, it's compact. From the third year, if you are thinking about, you can think like that, a closed bounded interval under a continuous map. From the calculus period, you say that it is again closed and bounded. That is what is it compactness means. Interval goes to interval under a continuous function. That is the replica of connectedness. Connected pieces are going to connected. You can't break up. So geometry differs with that. So there is an hybridization or a marriage between two fields, which is one is at the analysis side and it will keep analysis with the geometry or topology, or the other side is a group structure. That is the beginning of R. R as a group, it works the analysis well. So we are rich in structures within R from the whole track. You can analyze well. It is merely the beginning because it's an abelian small group R. You can work with any great groups on that, such things. That is why it is so important. So let me conclude with this. Fine. Thank you for your patience.
Thank you, sir.
Yeah.
Thank
If you
you,
have
sir.
anything, you can ask always. Okay.
എന്തെങ്കിലും ഡൗട്ട്സ് ഉണ്ടെങ്കിൽ സാറുമായിട്ട് ഷെയർ ചെയ്യാവുന്നതാണ്. ചാറ്റ് ബോക്സും ഉപയോഗിക്കാം.
Yeah, maybe I can stop the. Yeah. Thank you, Krishna Prabha. It's okay, fine. At any time you can look at. There's no harm in it, but in this, I will stop sharing, and if you want to discuss directly, you can discuss or at any time. I'm using the same one now, but okay. So can I see Vimal? Vimal only asked questions, and Sudarshan, Anjali. I just want to see you at least. If possible, just open. I mean, depending on the video there. If you are ready, you can open your video just.
So Anjali is there.
Yeah, fine, Anjali. Do your best, and yeah. So, what's your plan after this?
Anjali mute ആണ്.
Yeah, now it's coming. Yeah, fine.
സാർ ഇത് കഴിഞ്ഞിട്ട് എനിക്ക് നെറ്റ് കോച്ചിങ്ങിന് പോയി നെറ്റ് എഴുതണം എന്നുണ്ട്.
Yeah. Yeah, no, just write all other things. Shabana and somebody will help you. Definitely you have to write in some IAC or something like that, ISI or ISIS, TFR. That coaching, definitely it will come along with you. You have to give the other side, most important, right? research will come, or you can have some notion like that. That is better. Write all the exams, not merely this net. Okay, fine. I don't know what about Vimal and all, and Sudarshan also answered. All others are good. They may be, sometimes they may not be interacting, but try your best to reach at the good institutes. They will make you how to think in the proper way. Even a coffee table talk will give you a lot. Okay. Vimal is still there? I don't know.
Yes, sir.
Yeah. Can I see you if you don't have any problem in the bandwidth and all? Sudarshan, I don't know whether he's still there. Yeah, fine, good, very good. You can also work finely.
Yes.
So it is not only for one person. So do your best.
Thank you.
Next time we will meet in from some institute, I hope. Right?
Okay.
Okay. Thank you. Yeah. Sudarshan, I don't know whether he left out or not. If he's there, he will be coming. I don't know. So many are there, and anybody can interact with us. Fine. Yeah, it's okay. Okay, then. If you have any doubt at any time, you can use it. You can use my email or ID or something like that.
ഹലോ ദിവ്യ, കൺക്ലൂഡ് ചെയ്യാം.
കൺക്ലൂഡ് ചെയ്യാം. അഖിലേഷ് ഉണ്ടായിരുന്നു സാറിനോട് ഡൗട്ട് ചോദിച്ചേ. അഖിലേഷ്.
Yeah, sure. Yeah, Akhilesh, please. Yeah, he left out or yeah, please come. Yes. Akhilesh, where are you? You are from there itself, right?
Yes, sir. From Kerala.
Yeah, from which institute actually?
Yeah,
from
analytical.
Analytical. Yeah, fine. You are analytical here only.
Yeah, yes,
fine.
just join.
Yeah. Just joined. Very good. You know Sanjay also, right? Sanjay is my colleague actually. Sanjay, you met with him?
Yes, sir.
Yeah, fine. Okay, good. Yeah, please. Yeah.
Okay. Sir, now wind up here, le?
Yeah, sure. Akhilesh, you have to use some analysis facts. Akhilesh, just a minute. It's okay.
Yes, sir.
Why you have joined NIT here itself?
No, sir. Just I
Entered there.
I have,
Fine. It's good.
yeah, just joined. I'm
Yeah.
doing MSc from Panampalli College.
Yeah. Yeah,
But
you are from
discontinued
Chalapalli.
it from there, and yes,
Fine. Very good. It's a very
discontinued
good
from
team.
there and joined analytical.
Good. Okay. But try your best to reach at IITs, not NITs. You go for NITs or not NITs, not bad. I'm not saying anything like that. But for research, you must go for a TFR, definitely. Or abroad.
Yes.
Okay, good.
Yes.
Have a nice time. Thank you. Yeah.
സജിത് സാറിന് നന്ദി പറയുന്നതിനായി ഞാൻ സെക്കൻഡ് ഇയർ MSc അഞ്ജലി S കൃഷ്ണയെ ക്ഷണിക്കുന്നു.
ഹലോ ഓൾ. അപ്പോ സാർ സജിത് സാർ ഇവിടെ നമുക്ക് അനാലിസിസ് ഓൺ ഗ്രൂപ്പ് എന്ന് പറഞ്ഞ പാർട്ട് പോർഷൻ ആണ് എടുത്തത്. അപ്പം ഞാൻ വിചാരിക്കുന്നു എനിക്ക് ഈ ലെക്ചർ ഭയങ്കര ഉപകാരപ്രദമായിരുന്നു. സാർ കുറെ കാര്യങ്ങളൊക്കെ പറഞ്ഞു. പിന്നെ സാറിന്റെ ഇൻട്രൊഡക്ഷനിൽ തന്നെ സാർ പറഞ്ഞു സാർ ഇപ്പോഴും ഒരു മാത്സ് പഠിച്ചുകൊണ്ടിരിക്കുന്ന ഒരു സ്റ്റുഡന്റ് ആണെന്ന് പറഞ്ഞു. അപ്പൊ ഓക്കെ. അപ്പൊ സാറിന്റെ ഇൻട്രൊഡക്ഷനിൽ തന്നെ ഭയങ്കര സിമ്പിൾ ആയിട്ട് ഭയങ്കര പോസിറ്റീവ് ആയിട്ട് നമുക്ക് കാര്യങ്ങളൊക്കെ സാർ മനസ്സിലാക്കി തന്നു. പിന്നെ സാറിന്റെ ക്ലാസ് നല്ല ഉപകാരപ്രദമായിരുന്നു. ഭയങ്കര ഹെൽപ്ഫുൾ ആയിട്ട് തോന്നി. ഞാൻ വിചാരിക്കുന്നു നിങ്ങൾക്ക് എല്ലാവർക്കും ഇതേപോലെ തന്നെ നല്ല ഹെൽപ്ഫുൾ ആയിട്ട് ഉണ്ടാവുമെന്ന്. അപ്പോ സാർ താങ്ക് യു സോ മച്ച് ഫോർ യുവർ ലെക്ചർ. ആൻഡ് ഷബ്ന മിസ്, പിന്നെ കോർഡിനേറ്റർ ദിവ്യ മിസ്, സജീഷ് സാറ്, സുജിഷ മിസ്, സോഫിയ മിസ്, നമ്മളെ ഡിപ്പാർട്ട്മെന്റിലെ എല്ലാ ടീച്ചേഴ്സിനും, പിന്നെ ഇവിടെയുള്ള മറ്റു ടീച്ചേഴ്സിനും, പിന്നെ ഈ വെബിനാർ സീരീസിൽ പങ്കെടുത്ത എല്ലാ സ്റ്റുഡൻസിനും താങ്ക് യു സർ.
Yeah, thank you. Okay then. So can we?
Okay, thank you sir. ഞങ്ങൾ
Okay.
സെമിനാർ നടത്തുന്ന സാറിന്റെ ടോക്ക് വീണ്ടും പ്രതീക്ഷിക്കുന്നു.
Yeah, it's okay. I mean, Mogeri's college is not different from me at any time, not at seminar or anything. I will be always with you. It's okay. Fine.
Okay, thank you, sir.
Okay then. Bye. Yeah.
ബൈ സർ, താങ്ക് യു. ഫീഡ്ബാക്ക് ഫോം ഫില്ല് ചെയ്തോളൂ കേട്ടോ, എന്നിട്ട് പോയാൽ മതി എല്ലാവരും. അതിൻ്റെ ലിങ്ക് എടുത്ത് ഓപ്പൺ ചെയ്ത് ഫില്ല് ചെയ്തിട്ട് പോയിക്കോളൂ. അപ്പോൾ ശരി എല്ലാവർക്കും, ബൈ. ദിവ്യ പോവല്ലേ?
ഓക്കെ, ഞാനിത് ക്ലോസ് ചെയ്യുന്നവരെ ഇവിടെ ഇരിക്കാം, കുറച്ചു നേരം കൂടെ വെയിറ്റ് ചെയ്യാം.
ഓക്കെ
ഓക്കെ
ഓക്കെ, ഇനി അടുത്ത ആഴ്ച കാണാം അല്ലേ?
ഓക്കെ, see you.
ഓക്കെ, see you, bye.
Bye.